Thank you very much. I am indeed back presenting today, but in this case, I'm providing a presentation by my open source colleague, Andrea Amy from GeoSolutions, and he's responsible for super detailed slides, which he talks about with great enthusiasm. So I'm going to try and summon my inner Italian and go really quickly, but I just wanted to make sure that this topic was covered at the conference this week, because we are in the middle of a transition from the Generation 1 OGC services to the newer OGC API services. And I just wanted to reassure everybody that, hey, this is underway, and give an update on how the work is progressing. So thanks to Andrea for this content. So to begin with, we've got the OGCA kind of common elements for GeoServer. So we've set up the scaffolding for all the OGC API services in GeoServer. And to begin with, just visually, the common things they all have is an API definition, a collection of stuff. In this case, we've got some functions, which was donated by one of the services, and some conformances advertising what the server actually does. So this ends up as a landing page that's available as HTML or JSON. The conformance lists what optional parts are there, and the OpenAPI definition. So links everywhere. OpenAPI is made up of links, and you can see that the links often say what kind of formats available, JSON and so on. And we have support for a number of resource representations out of the box. JSON and HTML are assumed by a lot of the standards. And what you actually get back depends on your accepts header or the end of the URL, the path extension. And in some cases, there's a little format or query parameter. So there's a couple of ways to choose what content you get back. The way in which these standards are structured are with the core and then some optional parts. So looking at OGC API features here, we can see the part 1 and part 2. And if we go to the conformance page, we can say which ones GeoServer implements. And this actually presents a challenge for us as a project, because we traditionally only share software components, modules, when the standard is actually finished. And the OGC standards are not kind of designed that way. They're designed to have some parts that are finished, some parts that are in draft, and also allow for community extensions. So in this case, in GeoServer, out of the box, it'll enable all the conformances that are standardized and finished, but you do have access to optional functionality that's not quite complete yet. So for our GeoServer implementation, we've got one engine behind the scenes with multiple services. So we've got our feature engine, which hides behind all our WFS services, and OGC API features is listed right alongside of them. So if you disable WFS right now in GeoServer, OGC API features gets disabled as well. We're going to be refactoring the application a little bit for GeoServer 3, but just to let you know, for our implementation, we're considering OGC API features as one of the protocols that GeoServer supports. So here's what that looks like on the home page. You can see for the GeoServer feature services, you can see them all listed together on the same row. We do support HTML templates, so when you're browsing these services and looking at the output, you have full control over how the headers look, how you want things to be laid out, and so forth. I think we've got some examples of that later in the slides. Also, when you're configuring these services, the configuration screens for services and layers allow you to add a whole bunch of additional links. Depending on your national policies, you might need to link to specific things like a download link and so on. So licenses, metadata, Inspire tags, descriptions of metadata, and so on. Thanks to GeoNovum for sponsoring that work. So the first one we've got, and this is the first OGC API standard kind of published by GeoServer, is OGC API features, and we were able to obtain standards compliant earlier this year, thanks in part to funding by Gaia 3D and OSGeo UK. So we are certified for part 1 and part 2. So for part 1, this only lists the collections, and the only coordinate reference systems that are supported are WGS 84. Part 2, so the content here from part 1 can be GeoJSON, GML, any of the formats that GeoServer supports. And you can see how to do a query just with bounding box and date time. Within the collections, they've got links to the next and previous, and you get to set a limit of how many items you get back in a collection. For part 2, they add coordinate reference systems. In addition to the coordinate reference systems that can be reprojected or supported, we also write down the storage coordinate reference system, so you know the original. We also support filtering, and this is kind of interesting. So we do this by advertising the queryables, what attributes are available for you to query against, and it may be a subset of the actual attributes. And it may not even actually match any of the attributes. Sometimes there's a placeholder, any text, if you want to search against anything. When you're doing a queryable, you have your filter, the expression you're interested in, the filter language, a number of them are supported, and also the coordinate reference system for any geometries in your query. So here's an example using CQL2, which we added support for. We also have our traditional eCQL as like a community extension. And you can see that's represented in both JSON and in a text format. Other stuff that we're interested in, kind of property selectors, adding sorting. We've got our eCQL community standard. There's a query by IDs that we're interested in, but it's currently a draft standard. And then we're also looking at how to integrate search, which is kind of a mix-in provided by STAC, which allows you to do a post request. So what's missing? Part 4, create, read, update, delete. So we can actually manage the data. Part 5 for schemas, and then geometry simplification for part 7. But the core functionality is here. Okay, OGC API tiles. So this is the service that provides like a tile set for one or more data sets. We've got the core implementation here that's a finalized specification. This is a building block API, so it's designed to mix into other data sets, whether they be features or coverages. GeoServer has a full implementation that's site compliant, but we don't have the sticker yet. We need we need a fix to be applied to the test engine. The way in which it works for tiles, and this is interesting, for OGC API, normally you have links to content that you can follow. For tiles, it's actually a fill-in-the-blank template where you fill in with the tile matrix in the row and the column in order to get a recipe for how to request tiles. So the metadata resource describes the templates that you can fill in and how to do the autocomplete. For OGC API processes, this enables you to execute processes on the server side. We've got part 1 implemented, and this is, once again, the final specification is available. In this case, it's a building block. It allows you to enumerate, describe, and execute processes, JSON-based, and it supports synchronous or asynchronous execution. We've got a recent implementation, and we've provided like a few extra capabilities that we're interested in. We are ready to pass certification tests on this one. So one thing that's interesting, if you go to this service endpoint, there's no actually collections here. It only lists processes that you can execute. And you can go through the processes and see what operations are supported, and go through and look at the parameters and how to make use of them. You issue this with a standard post request, so you can take your JSON inputs, submit it to the endpoint, and get the output. And the addition that we've done is also allowing you to do this from a get URL as well. So you can see in this case we've encoded some of the parameters in the URL in order to execute the request. Next up, we've got coverages. how to access raster data or imagery. And this is actually nice. This standard is far easier and more simple to understand than the traditional WCS services. So currently it's a draft standard. It's very, very simple. Collection is represented as a single coverage, and we've got a partial implementation from a code sprint, but this is something we'd like to see progress. Here's an example of how to do a coverage extraction. You can see you've got the format and the bounding box, or you've got the format of a subset or a subset in lat long. In both cases, this will produce a subset of your coverage. There's other things we're interested in here, doing scaling and tiled coverages, and there's functionality around describing some sub-images. So if folks are interested in that, please contact us. Andrea does such detailed slides, it's kind of fun to try and keep up here. OGC API maps. So this is a service where you're building up maps, a visual representation on top of the raw data. And so this one's a little bit more like a Lego set, where we need to combine some styling and the raw data in order to produce a visual. So one thing that's interesting for GeoServer is we have everything defined as an independent service. So our maps is an independent service from OGC API features. And the Maps API provides the notion of a style, which we can use to draw the data, and mixes it in with a map resource in order to get an output. So here's an example of our endpoint. Trying to think what here. We also have added a new operation of our own, which is info. So this is where you're able to provide a IJ offset into an image and discover what feature or what content is located at that space. So that's not part of the standard. Just checking my time because I heard a ding. Other OGC APIs is the STAC API. So this is the spatial temporal asset catalog. We've got an implementation compatible with features. And here's an example of this customized with headers and item presentation in order to have something that looks visually distinct. Here's an example of OGC styles. This is a draft standard. It's another one of these building block APIs. And we've got an implementation based on an early draft. What we've got here is the style identifier, some metadata about how it works, what style sheets, what's the native format is, and what layers are capable of using this style. Another one we have is the discrete global grid system. So these are where you define an area, the nesting pattern, in this case, little hexagons. So what's interesting here is all of the relationships between parent and child and neighbors are done by reference. So it allows you to do queries just based on those relationships and not having to do like geospatial operations. And so using this as a framework, you can run processes that explore your data in this space. So we can see some of those kind of things, retrieving data, doing aggregates and so on, using the DGGS framework. Moving forward, where we're going next. So here's what we've got right now. We've got processes and tiles that are ready to be certified. In some cases, we're waiting on funding or fixings from the OGCs, but when these pass certification, we'll be able to make them available as a formal extension. We've got a whole host of standards where the work is in progress. Sometimes the work is incomplete, and sometimes the standard is incomplete. But this is all activities we'd like to see progress. And the only one we have completely missing here is the Records API. We have the Catalog Service Web implementation in GeoServer, but we don't have the corresponding OGC API records. So yeah, if you are interested, please help join development and help push these over the finish line. The other way we could use your assistance is simply try things out. Promote the use of OGC API, deploy these services alongside your GeoServer, and yeah, enjoy. These services are very much more accessible, being REST and JSON based. What else do we got here? Also, just start to plan your migration to the OGC API services. And if you were a developer, the back-end infrastructure to support development is far more straightforward and easier to understand. So we've got nice objects representing all the core ideas. So working on these new services is also very straightforward and enjoyable. Any questions? I think I might be ahead of time. One question. I have to give you a mic.
Thanks, Jody. You were mentioning that you're waiting for being certified.
Correct.
Can you explain a little bit more on what you mean with the fixing of tests?
Right. I think this microphone works.
Yeah.
So the OGC API services, the OGC API certification in general has a test engine, and in order to obtain certification, you have to set up your service, ask the test engine to try it out, and you get a little sticker saying if you pass or fail and how many regressions you have. And only if your service follows the standard and passes this test do you have an opportunity to pay money and be certified for the next calendar year. And these tests operate as kind of like black box testing on our GeoServer implementation. And then it also offers some reassurance to the public that if they are running GeoServer and it's passing this certification, that it can interoperate with any of the clients that have been developed with these standards in mind.
Why it fails and why you need the fixes? Are the fixes on the GeoServer side or on the OGC side?
True. So for some of these, yeah, so for, the stars went away. So I think for OGC API tiles, we're actually waiting for a fix on the test engine. We've provided a fix for a test engine, and we need to wait for the fix to be merged. And then for one of them, we pass on the newer, like version 2 test engine, and we have to wait for that one to become the mainstream. Thanks.
Who else had questions? There was someone back here.
Yep.
The GeoServer has so many features, it has everything. But I saw some work in the deployment area where you are doing what I think is called like the modulith instead of the monolith. GeoServer can be a bit of a monolith with everything in one.
Yep.
How is that progressing, that you can deploy the features independently if you only need some of them and not have a big instance of GeoServer?
Oh, I understand your point. So internally, GeoServer is structured as a modular application, and we do provide like the initial sample core application and then extensions that you can use to add in the components you use. There's two other ways forward. There's the cloud-native GeoServer, where a lot of the services have been broken out into individual Spring Boot apps. That might be the one you're referring to. But also as a developer, and we do this at GeoCat, we offer a cut-down GeoServer for our customers, and then we only add in the services that they're specifically interested in. So I'm not sure which one you meant, but there's lots of flexibility there.
I guess it's a different presentation about the cloud-native GeoServer at some point, yeah. Thank you.
The developer behind that, Gabriel Roland, is not here at this event. Yeah. Thanks.
Is there anyone else with questions?
Okay. I will just end with a nice little slide showing the internals and how straightforward they are because, you know, I'm a developer. So thanks, everyone. Oh, one more from your own.
We have time. Can you say anything about the performance comparison between the old OGC standards and the new ones?
So the question was, can I say anything about the performance between the old standards and the new ones? I can't say very much because really it's the same engine behind the scenes, GeoServer, and we're just changing which protocol. So it's a little bit comparable to whether you go through in WFS2 or WFS1, you still get the same GML output or the same GeoJSON output out of the service. So I don't expect any performance differences.
Thanks.
Yeah. Usability differences, though. Yeah. Well, thanks, folks. Anything else?
Thank you all for coming and thank you for presenting.
Okay, thank you.